Diseases of Ear, Nose and Throat and Head and Neck Surgery by P.L. Dhingra. Chapter 3, Audiology and Acoustics. This section aims to introduce certain terms which are frequently used in audiology and acoustics. Sound. It is a form of energy produced by a vibrating object. A sound wave consists of compression and rarefaction of molecules of the medium, air, liquid, or solid, in which it travels. Velocity of sound is different in different media. In the air at 20 degrees Celsius at sea level, sound travels 344 meter per second, that is 1120 feet per second, and is faster in liquid medium and is still faster in a solid medium. Frequency. It is the number of cycles per second. The unit of frequency is Hertz, HZ, named after the German scientist Heinrich Rudolf Hertz. A sound of 1000 Hertz means 1000 cycles per second. Pure tone. A single frequency sound is called pure tone. Example, a sound of 250, 500, or 1000 Hertz. In a pure tone audiometry, we measure the threshold of hearing in decibels for various pure tones from 125 to 8000 Hertz. Complex sound. Sound with more than one frequency is called complex sound. Human voice is a complex sound. Pitch. It is a subjective sensation produced by frequency of sound. Higher the frequency, greater is the pitch. Overtones. A complex sound has a fundamental frequency, that is, the lower frequency at which a source vibrates. All frequencies above that tone are called overtones. The latter determine the quality and or the timbre of sound. Intensity. It is the strength of sound which determines its loudness. It is usually measured in decibels. Some examples of intensity at a distance of 1 meter are as follows: whisper 30 decibel, normal conversation 60 decibel, shout 90 decibel, discomfort of the ear 120 decibel, pain in the ear 130 decibel. Loudness. It is a subjective sensation produced by intensity. More the intensity of sound, greater the loudness. Decibel. It is one tenth of the bell and is named after Alexander Graham Bell, the inventor of telephone. It is not an absolute figure but represents a logarithm ratio between two sounds, namely the sound being described and the reference sound. Sound can be measured as power, that is, watts per centimeter square, or as pressure, that is, dynes per centimeter square. In audiology, sound is measured as sound pressure level, SPL. It is compared with the reference sound, which has an SPL of 0.0002 dynes per centimeter square or 2 micropascals, which roughly corresponds to the threshold of hearing in normal subjects at 1000 Hz. Decibel notion was introduced in audiology to avoid dealing with large figures of sound pressure level 0.0002 dynes per centimeter square at normal threshold of hearing to 200 dynes per centimeter square, which causes pain in the ear. The latter is 1000 10 lakhs times the former. Formula for decibel. Sound in decibel 10 log power of S1 by power of S0. S1 sound being described, S0 reference sound, or 10 log SPL of S1 square by SPL of S0 square, because power of square is proportional to square of SPL, or 20 log SPL of S1 by SPL of 0. If a sound has SPL of 1000, that is 10 raised to 3, the reference sound, it is expressed as 20 into 3 equal to 60 decibels. Similarly, a sound of 10 lakhs, that is 10 raised to 6 times the reference sound SPL, is expressed simply as 120 decibel, and so on. Noise. It is defined as a periodic complex sound. There are three types of noise: white noise, narrow band noise, speech noise. White noise, it contains all frequencies in audible spectrum and is comparable to the white light, which contains all the colors of the visible spectrum. It is a broadband noise and is used for masking. Narrow band noise. It is white noise with certain frequencies above and below the given noise filtered out. Thus, it has a frequency range smaller than the broadband white noise. It is used to mask the test frequency in pure tone audiometry. Speech noise. It is a noise having frequencies in the speech range 300 to 3000 Hz. All other frequencies are filtered out. Masking. It is a phenomenon to produce inaudibility of one sound by the presentation of another. In clinical audiometry, one ear is kept busy by a sound while the other is being tested. Masking of non test ear is essential in all bone conduction tests, but for air conduction tests, it is required only when difference of hearing between two ears exceeds 40 decibel. Sound pressure level. The sound pressure level of a sound is in decibels is 20 times the logarithm to the base 10 of the pressure of a sound to the reference pressure. The reference pressure is taken as 0.0002 dynes per centimeter square or 20 micropascals for a frequency of 1000 Hz and represents the threshold of hearing in normally hearing young adults. Frequency range in normal hearing. A normal person can hear frequencies of 20 to 20,000 Hz, but in routine audiometric testing, only 125 to 8,000 Hz is evaluated. Speech frequencies. Frequencies of 500,000 and 2,000 Hz are called speech frequencies because most of human voice falls within this range. PTA, pure tone average, is the average threshold of hearing in these three speech frequencies. It is roughly corresponds to the speech reception threshold. Audiometric zero, threshold of hearing, that is, the faintest intensity which a normal healthy person can hear, will vary from person to person. The International Standard Organization ISO adopted a standard for this, which is represented as the zero level on the audiometer. According to ISO, audiometric zero is the mean value of minimal audible intensity in a group of normally hearing healthy young adults. Hearing level. It is a sound pressure level produced by an audiometer at a specific frequency. It is measured in decibels with reference to audiometric zero. If an audiometer delivers a sound of 70 decibel, it is represented as 70 decibel hertz. Hearing level. Sensation level. It refers to the level of sound above the threshold of hearing for an individual. If someone is tested at 40 decibel sensation level, it means he was tested at 40 decibel above his threshold. For a normal person, this would be a sound of 0 plus 40, that is 40 decibel hearing level. But for one with a hearing loss of say 30 decibel, it would be 30 plus 40, that is 70 decibel hearing loss. In other words, sensation level refers to the sound which will produce the same sensation as in normally hearing person. In speech audiometry, discrimination scores are tested at 30 to 40 decibel sensory sensation level. Stapedial reflex is elicited with a sound of 70 to 100 decibel sensation level. Most comfortable level. It is the intensity level of sound that is most comfortable for the person. Loudness discomfort level. It is a level of sound which produces discomfort in the ear. Usually it is 90 to 105 decibels sensation level. It is important to find the loudness discomfort level of a person when prescribing a hearing aid. Dynamic range. It is difference between the most comfortable level and the loudness discomfort level. The dynamic range is reduced in patients with positive recruitment phenomenon, as is the case in cochlear type of hearing loss. Sound level meter. It is an instrument to measure level of noise and other sounds. Sound level meters have different weighting networks, example A, B, or C, for different sensitivities at different frequencies. When describing a sound measured by a sound level meter, the weighting network must be indicated. Noise levels are often expressed as decibel A, which refers to sound pressure level measured at A network, where the low and extremely high frequencies are given much less weightage compared to those in the middle range, which are more important and are responsible for noise induced hearing loss. Thank you.